All right, the next thing that we're going to talk about in this section, or review in this section, is going to be talking about representing and analyzing data. The material in this presentation comes from section 1.2 of the textbook. Okay, so let's just go through some key terms and concepts to get us started. The main thing that we're going to talk about is we are talking about data in this section. And we're going to talk about data that involve an input or an independent variable and an output or the dependent variable. Okay, so what does that mean exactly? Let's start off with independent and dependent variables. A general way to think about independent variables is these are things that change without our control. They do what they do independent of what we want them to do. A wonderful example of an independent variable is time. Time is usually an independent variable. If you think about the phrase time marches on, well, we have no control over it. On the other hand, dependent variable. This is going to be the thing that we are measuring, and quite often this value depends on the input that we plug in for the independent variable. So for instance, how does a child's height or weight change after over the years? Again, we have no control over the years, and you can argue that we don't have any control over the height or the weight. But the height and the weight, that's what we are trying to measure as we progress. You take your kid to the doctor, they take measurements, and they record them. You can also think about how far have we traveled after we left the house. And so that's another one that's dependent on time. All right, data can be represented using a variety of techniques. Some of the ones that we're going to see is we have tables where we have X's and Y's, we have inputs and outputs, and we organize them using a table. We can also describe data using ordered pairs or points, X, Y, and those points can be graphed. And so plotting numbers on the number line or in the coordinate axes. We can also represent data using equations with one or two variables. And the last one is we can also use function notation. Okay, so now the thing that we do want to talk about that we're going to really be focusing on is we're going to see the term relation. And relation, just so you know, this is just a set of ordered pairs. A relation is just an input and an output. And each input goes to the output. That's what we call a relation in mathematics. Now, in terms of relations, we have two things. We have something called the domain. And the domain, this is the set of all inputs. And for most of the things that we're going to be looking at, these are the X values. The other thing that we have is the range. This is the set of all outputs, or the Y values. Other concepts that we are going to look at over the course of this semester, we are going to be playing around with domain and range a lot. But we're also going to be talking about maximum and minimums. These are the largest or smallest values. Now, when we say values, we do want to be careful because values are represented by numbers. They are not points, they are just numbers. The maximum value is 5. Okay? And so these are going to be concepts that we're going to look at over the course of this semester, and we're going to use various terminology to explain the same thing. So just keep in mind that these things are going to come up many times, and we'll see them again. Okay? All right. Let's go ahead and let's look at some examples. All right, the first thing that we're going to look at is we are going to look at a table, and we want to be able just to kind of pull numbers and rewrite things different ways. All right, so the first thing is we have our months, 1 through 12, and we have our precipitation, or the amount of rainfall we have in inches. So we do want to start by expressing the data as a relation, meaning that we want to write ordered pairs. So if we write this using ordered pairs, well, we have 1, 6.2. We have 2, 3.9. We have 3 and 3.6. We have 4 and 2.3. And hopefully you guys get this. I don't want to write them all out and make this video even longer. But basically, for every input, we have our X values. Our months, we have no control over that. And our precipitation, this is what we are wanting to look at. And so these are the Y values. And so when we write these as points, we put a month, comma, its corresponding precipitation. All right. So if you're okay with that, you can do the rest of this for the rest of the months. Okay, we do want to identify the domain. And so our domain is going to be the first row. So this is our inputs, and our inputs are the months. This is our independent variable. This is the one that we have no control over, and so we have 1, 2, 3, and we're going to go all the way to 10, 11, 12. Okay? Make sure that these dots that you do actually put in all the numbers. So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, for our range. One of the things to note is it does not matter what order we write this in. I am going to kind of try to organize this a little bit. Essentially, we just need to list them out. But as we are going to be looking at for the next couple set problems here, what is mean, what is medium, what is minimum, what is maximum, I'm going to go ahead and arrange these from smallest to largest. So for here, I see it looks like my smallest is 0.5. We have 1.1. 1.5 and 1.6. We have 2.0 and 2.3. We have 3.1, 3.6, and 3.9. We have 6.2, 6.2, and 6.4. And so there are all of those. Okay. Let's go ahead and go down and look at our minimums and maximums. Okay, our minimum X value. Well, again, the main thing I do want to point out is it does say value, which means just a number. And we are looking at our domain. And so our smallest number in the domain is 1. Similarly, for part D, we have what is the maximum X value. And so the largest number in our list for our domain is the 12. And so that's going to be our maximum X value. All right, let's come over to our y values. And this is one of the reasons that I did want to kind of rearrange these, is because we can do the same thing now. My minimum y value is my smallest. It doesn't matter where it occurs, but it is going to be 0.5. And similarly, my maximum y value is going to be the largest of these y values. It is going to be 6.4. Now, one of the things I do want to point out up here is that when we talk about these minimums and maximums, notice it doesn't matter where they occur. So, for instance, my minimums for my x values is the far left and the far right. But when we talk about the y values, notice that they can appear anywhere in here on our list. My maximum y value does happen to show up on an edge, but my minimum shows up somewhere in the middle. And so this is something that can happen. And this is one of the things that we want to be aware of when we start working on problems as we progress through the rest of the material. All right, the next thing that we want to do is we want to know what is the mean precipitation. Okay, so which ones are the precipitations? These are the y values. And so what we want to do is, how do we calculate a mean? This is another word for average. So we want to start by adding up all of the numbers here in our range. And so if we add up these values, I don't want to write it out again, we get 0.5 plus 1.1 plus 1.5 plus 1.6 plus 2 plus 2.3 plus 3.1 plus 3.6 plus 3.9 plus 6.2 plus 6.2 plus 6.4, and I get 38.4. Now that's the first thing that we need to do when we find an average, is we want to add up the numbers, and then I want to divide by how many there are. And so because there are 12 months, we are going to divide by 12. And if I do that, I get 6.5, I think is, no, that's not what I got. I got 16 over 5, and 16 over 5, that I believe is equal to 3.2. And that is our mean, or our average. All right, the other thing that we have that comes from statistics is median. And median is the number that is in the middle. We already have these rearranged. The first thing you always have to do is rearrange from smallest to largest. And for this, I want to find, because there's an even number of values, I want to find the two numbers that are in the middle. And so I have 2.3 and 3.1. We are going to find the average of those two numbers. And so if I add those up, I get 2.3 plus 3.1 is 5.4. And I want to divide that by 2. And if we divide that by 2, we get 2.7. And that is our median. Because we are talking, we should go ahead and include correct units so that we know what we're looking at here. So just so you know, average, everybody knows averages. We play around with averages a lot, especially in school. Your instructors calculate your averages. Median, when you get into the real world, what's the difference between average and median? Well, median, what it does is it kind of excludes the ones that are over on the very far sides. If you notice, my median is smaller than my average. These 6.2s and 6.4s that are here, they're quite a bit further away from everything else. And so in our average, they have a big, they have a large impact on my value. Whereas when we look at median, my median kind of is more in the middle of everything, and anything that's really extreme doesn't affect the median value. All right, that takes care of this example. We're going to look at one more. So the last example that we're going to look at is we're going to be given some points, and we want to go ahead and do kind of the same thing, but we already have them as points. All right, so the first thing we want is we want our domain. And so our domain, what we have here is we have the x values again. What are our inputs? And so you can go ahead and write these in, again, in any order. If you want, you can go smallest to largest because we are going to be asked for maximum and minimums here in a minute. We've got -15, -10, 0, and 5 for our domain. And for our range, we have -10, -5, 10, and 15. Okay, maximum and minimum x values. Our maximum x value is 5. Again, remember, values means numbers. Our minimum x value is -15. We want the maximum and minimum for the y values. Our maximum y value is 15, and our minimum is -10. Okay, largest and smallest. All right, the main reason I wanted to do this problem is I do want to talk about graphing using a scale on axes. When you graph in the homework, it's pretty much going to be given to you, but you do want to kind of be able to figure out what would be a good scale for this, for problems to help you out. Okay, we're going to plot the points, but we do want to find and label an appropriate scale on the axes. Now, when I look at these points up here, when I look at my numbers, to me, all of these are divisible by 5. Same thing here. And so that is probably going to be a good scale. Instead of having to write out, 15 tick marks on each side, we won't have to do that if we use a scale other than 1. So what we're going to do is I'm going to use a scale of 5. So we have 5, 10, 15. On the other side, we have -5, -10, -15. We can do the same thing going side to side. So we can do 5, 10, 15. We can do -5, -10, -15. If you want, you could also go with 3 since we have 5 tick marks here. But let's see here. Okay, now we want to go ahead and plot these points. So we have 5, -5. Remember, points, we are going to go left and right and then up and down. So here I want to go 5 to the left. Again, we're using a scale, and I want to go 5 down. And so my point is going to be right here. The next point we have is -10, 10. So that tells me I want to go 10 to the left. So remember, each one of these tick marks is 5. So we're going to go 5, 10. And then I want to go 10 up, which is 5 and 10. So this is where my point will end up here. All right, the next one we have is 0, 15. And so 0, 15, be very careful with this one. 0, 15, we are not going to go left and right because my first number is 0. But I do want to go up 15. So we're going to go 5, 10, 15, and we will end up here. And then my last one, negative 15, negative 10. If we plot this, we're going to go 15 to the left. So we have 5, 10, 15 to the left, and 10 down. We go 5, 10 down, and so we should end up right here. And that's what we have. Okay. So as I mentioned, I went with a scale of 5, but you can go with any scale that you want that is within reason. Just remember that when we scale this, we do want to make sure that our tick marks are consistent. You can't sit here and say, okay, I'm going to go, this is going to be 3, this is going to be 10, this is going to be 15. You do need to make sure that your scale is consistent. They need to be the same distance apart. So for instance, if you're going to go 3, it has to be 3, 6, 9, 12, 15. And it has to be the same on the other side. As long as your scale on your X's are consistent, they can be different, but the scale on your Y has to be consistent as well. All right, that takes care of this part of the section. The next section, we're going to continue looking at our definition of functions and domain and range and these concepts of maximum and minimum.